Hello, Professor. This is going to be my individual assignment for unit testing. This will be for. Hello, Professor. This is going to be my individual assignment for unit testing. We're going to be discussing testing contained within software engineering. All right, let's begin. So, some of the topics that we're going to discuss during this, for right now, I'm going to change my visual just so it's easier to read. I'm not covering anything. All right. So, we're going to test topics during software. We're going to test. We're going to be looking at our testing topics. First, we're going to start off with what is software testing? What type of tests what type of software tests we will be performing. We're going to get an introduction into unit testing. We're going to discuss what unit testing is. We're going to look at what test-driven development is. And we're going to talk about what is test-driven development. We're also going to discuss why do we do unit tests. We're going to look at what unit testing is in practice with JUnit. We're going to look at the practical test pyramid. We're going to look at what integration tests are. We're going to see what system tests are. We're going to look at what acceptance tests are. And we're going to look at what JUnit is and what frameworks can be used for testing. We're going to look at testing softwares and what automated testing is. And we're going to discuss best practices when performing software tests. I'm going to include in my slides a terminology page and an annotations page as provided from the JUnit website. I'm just going to adjust these slightly for what we're discussing currently in our presentation. All right, let us begin. So, what is software testing? Software testing is the process of evaluating and verifying software applications or systems meet the requirements and functions as intended. It helps to ensure that software is reliable, functional, and secure. There are several types of tests, including unit testing, integration testing, system testing, and acceptance testing. Each of these testings follow a very specific purpose for confirming our tests. Testing can be manual or automated depending on the requirements and resources available. And can make testing can be used to develop our projects to be more scalable and efficient over time. Let's look at types of software tests. We have unit tests, integration tests, system tests, and acceptance tests. For now, in this PowerPoint, we will focus on these four, and we'll discuss each of these in more detail. For a unit test, we focus on testing the individual components or functions in isolation to ensure that each part of our unit test performs correctly. For our integration tests, we are evaluating the interactions between different components or systems to verify they work together correctly. For our system tests, we're evaluating the software, simulating real-world scenarios to check if the entire system meets the requirements. And for our acceptance tests, these will be conducted by the end user or stakeholders to verify that the system meets business requirements and is ready for deployment. Our acceptance test will be the last test we perform before we release our project. Let's move on. So we're going to get an introduction into unit testing. So what is unit testing? Unit testing involves performing tests on individual components or isolated functions to validate and verify the behavior of code. So, in other words, we're testing small parts of code instead of the overall functional project to see if each part functions as intended by the user. Programmers conduct unit tests to identify discrepancies between expected and actual behavior. Sometimes our code can perform out of the ordinary and do unexpected things, which can lead to bugs and cause some issues in post-production after our code is released. Additional reasons why we perform unit tests are to identify and fix these bugs, to ensure functional components perform to expectation, to allow for easier code adjustments and changes over time, and to improve code quality and maintainability. Here, we're going to look at test-driven development. As we follow in our graphic right here, we're going to look at where it says write a list of test cases. So we're from those lists of tests, we're going to pick one test. We're going to move on to writing the code for the test. We're going to see if the code is passable and see if the test makes it. And we're going to see if the test makes it. And we're going to see if the test passes. We're going to refactor our tests to create it more efficiently and functional. Then we're going to update the list as we learn. So when we perform tests, we want to write a test that defines the functionality you intend to implement. We want to develop the functionality. We want to develop the functional code until the test passes successfully. We want to refactor both the new and existing code to enhance structure and clarity. And we want to update the list of test cases based on insight gained from the testing process. Next, we're going to discuss what is unit testing. Unit testing is a unit test checks a single function or method to ensure it produces the correct output for its given inputs. So we could either choose a single function and test that, or we can choose a method and test that individually. A unit test should be independent, repeatable, and run in isolation from external systems such as a database and APIs. A good unit test uses assertion to compare the actual result to the expected result, confirming its correctness. So why do we unit test? Here are reasons for performing unit tests. The reasons why we perform unit tests are to see if the software meets the requirements and performs the tasks for which it was designed for. If the program or function or method that we are testing does not meet its requirements, we're going to have some issues and we're going to have to refigure our code. We perform unit tests to identify bugs or defects that could negatively impact the user's experience or cause system failure. If we are unable to fix these mistakes, our code will fail and it could actually cause our system to fail. We perform unit tests to improve the software quality. We also do it to improve user satisfaction. And we perform unit tests to reduce the risk of post-process release issues. We perform unit testing to verify that software is scalable, secure, and compatible with different systems or environments. Unit testing in practice with JUnit. JUnit is a testing framework for Java applications that allows users to write and run tests quickly and efficiently. JUnit provides annotations such as @test, @before, and @after to organize and manage testing, allowing for consistent results. JUnit integrates easily with build tools such as Maven and Gradle and work well with continuous integration systems. Other frameworks like TestNG or Spock offer similar functionalities but vary due to the unique need of the testing framework or the variations of the programming language. Now we're going to look at the practical test pyramid. The practical test pyramid is a testing strategy emphasizing fast, focused testing and fewer slow, comprehensive tests. At the bottom, we have our unit tests. In the middle, we have our service tests. At the top, we have our UI tests. The closer we get to the top, we have more integration and we have slower testing. And at the bottom, we have more isolation for our tests and faster testing. So as we go through this, we're going to look at our base. So at our base is our unit tests, which are fast and isolated. This means that the test code is in small parts. There are a large number of tests, and these tests finish quickly and provide quick feedback. In the middle, we have integration tests, which are more moderate in speed. They test our interactions between software components. There are fewer unit tests, and there is broader coverage of our testing service. At the top, we have our UI tests, which are our slowest tests. These tests test the full application. They have the least amount of tests, and they check the overall experience. So just an overview of what this is. We have fast tests in many different scenarios, all the way at the bottom for unit tests, and all the way at the top we have very, very slow tests, very, very few tests, but it checks the whole application as a total amount. Next, we're going to look at our next steps in software testing. We're going to look at integration tests. Integration testing checks how different software components or systems work together. Integration tests ensure that our components work together properly, so there's complete functionality between our system. Integration tests allow for data flow correctly between components of the program and for combined modules to function as expected. Integration tests can be used to discover issues like a broken interface, a data mismatch, or a miscommunication between modules. And integration tests can be used to test the correctness of our functional and non-functional requirements contained within our software. Now we will be looking at system tests. System tests validate the complete and integrated software system to ensure it meets all specific requirements. This means in our system tests, we want to verify that the entire system functions as expected. These are going to be slower tests. Function tests simulate real-world conditions to check the overall functionality, performance, security, and additional non-functional requirements of our system. System tests involve functional testing, ensuring that our software works, as well as non-functional testing to see our load and stress test our system. Lastly, we'll have acceptance testing. Acceptance testing is performed to verify whether the software meets the business and user requirements before the software is sent out for deployment. Acceptance testing will validate that our system meets our user requirements. Acceptance testing ensures that the product satisfies the needs of the end user and is prepared for release. And acceptance testings can be performed by the customer or a designated testing team validating the use of software and its reliability in production. We do acceptance testing to make sure that our program is completely finished or our software is completely finished before it goes out for release. The purpose of acceptance testing is to make sure that everything works as intended. So let's talk about testing softwares that we can use and automated testing. So when we are looking for our testing software, developers can use tools or frameworks to write, execute, and manage tests. Testing tools include JUnit, Selenium, and TestNG. The reason why we choose between different types of testing software is for the functionality or the requirements that are needed for our tests. Some people use products to test products for different systems, different coding languages, different overall functionalities, and each testing tool can be used in a similar manner to perform tests to check the functionality and overall requirements of each system. Now, let's talk about the automated functionality. This is something that we would want to use in our testing software to make sure that tests are more consistent, we have more tests available to us, we're constant with our tests, and we're overall testing a massive amount to make sure that there are no bugs or issues within our software. Automated testing allows developers to run tests frequently and consistently without manual intervention, increasing testing efficiency. By having automated testing, we can provide more tests, we can provide efficient tests, and we can target our tests to make sure that our system is working properly. Automated tests can be run as part of a continuous integration pipeline or a CI pipeline to ensure the software's quality with each new code change. We want to make sure our code is we want to make sure our code is efficient, and we want to make sure our code is scalable, and automated testing can help us in providing that. Now we'll talk about best practices when performing software tests. So we're going to want to start our testing in our software early. We're going to begin by writing our tests early in the development process to catch issues sooner and ensure consistency and quality within our software. We're going to test small isolated parts. So we're going to focus on testing individual components as we're performing our tests, which are unit tests, before assessing their interaction with the system, aka integration tests. We're going to attempt to automate as many tests as we can wherever possible. By automating repetitive tests, we can save time, improve consistency, and maintain our system, testing our loads and balances, making sure that our system doesn't fail on us through massive use, especially during the regression testing of our system. And lastly, we can maintain the test code is readable and it is clear. We want to ensure that the test code is clean, well documented, and easy to understand to avoid confusion and ease future modifications. If we have disorganized test code, we're not going to know what we tested. We're going to perform additional retests, and as we're going about this process, we're going to find more issues over time with the stuff that we're testing that either don't exist or are redone due to disorganization and failure. Here are some annotations provided by JUnit from their website and other resources, just to see what we can use in our testing software. For JUnit, we can use @test, which marks a method as a test case to be executed by the testing framework. We can use assertions, such as assert equals, assert true, assert false, assert null, or assert not null, to check if the expected results are equal in value, to check if they're true, false, check if an object is null, and to verify if an object is not null. We can use @before to specify a method to run before each test case, typically for setting up conditions. We can use @after to specify a method to run after each test case, typically to clean up tasks. We can use @ignore to temporarily disable a test method, preventing it from starting when executed. We can @before class to mark a method to run once before all tests in the class, used for a one-time setup. We can use @after class to mark a method to run once after all tests in the class, used for a one-time cleanup. We can use @runWith to specify a custom runner to control how the test runs, such as parameterized tests. We can use parameterized tests to mark a test method to run multiple times with different sets of parameters. We can use Mockito, which is a framework for creating mock objects in unit tests to isolate dependencies. That's very useful in testing. And we can use @mock to specify that all objects should be mocked, typically used with Mockito to stimulate behavior. So our mock tests would be used as example tests. Here are some key terminologies in software testing. These are provided by some of the resources that were provided on the individual assignment PDF. We have our test case to set a condition or variable to determine if a software application behaves as expected. We can use test suite as we have test case, we have test suite, we have test plan to understand the scope of our tests. We can have terms such as bug defects to understand what our bugs are and what we should be checking for. We have regression testing to test the overall functionality to ensure new code doesn't break previous code. We have smoke testing to check the basic functionality to ensure critical failure doesn't occur while we do more detailed testing. we have our sections for what type of tests we would run, such as black box testing and white box testing. Black box testing would test based on functionality without knowledge of internal code structures, focusing on inputs and expected outputs, while white box testing is internal structures and logics of the code, often involving code path and verification. We have automated testing, performance testing, acceptance criteria, and test coverage. Automated testing is use of automated tools to do our tests. We have performance testing. Test the software performs as expected, doesn't get overloaded, doesn't slow down, is more stable. Our acceptance criteria is what meets our requirements. And our test coverage measures how much the application or code functions in its evaluated. And we have test coverage, which is a measure of how much of the application's code or functionality is evaluated by the test case. We can use mocking or stubbing techniques, which is used in unit testing to simulate external dependencies. We should know what continuous integration is, which is a practice where code changes and are automatically assessed and integrated into the main code base. And we should be aware of what failover testing is, which is when testing the software ability to recover from hardware or software failure ensures business continuity in case of issues. Now we're going to review some of the code to understand what testing software is. Here we have a basic class for a bank account. We have it set up for getting the account balance. This is just overall setup code for creating the bare basics of a bank account. But we're just using this as an example for viewing our unit tests, system tests, integration tests, and acceptance tests. So for our unit tests, in our unit tests, we want to verify that the individual components work correctly. So we're going to import our JUnit to be able to perform our tests, and we're going to get our assertions so we can use our code. So for our tests, we're going to see if the deposits work correctly. We're going to test to see if we're withdrawing money correctly. We're going to check to see if when our accounts go negative, to see if that's functioning correctly. And we're going to test inefficient funds for when the account is empty or when the account doesn't have money, so that we don't have negative values appearing when it's not supposed to. This type of testing is very broad. We can do many tests like these. These are very short, and these cover a lot of bases. We could add dozens and dozens more. These are just basic examples of how we can do unit tests. Now let's look at system testing. Here in our system tests, we're testing by creating multiple accounts and for test interaction. We're simulating a complete banking workflow. And we are testing the boundaries of our system. We're testing our deposits, our withdrawals. We're testing the overall functionality of our system. When we test our limits, we're testing to see if everything is functioning properly. And in our system test, we are verifying the entire system functions as expected. All right, let's look at our integration test. So here in our integration test, we're testing by testing a series of deposits and withdrawals. We are simulating a complete bank workflow. We are testing to see if the account information is correctly maintained throughout our system. And we're testing the functional and non-functional requirements present within our software. These are going to be a medium level test. So there's going to be a fewer tests provided. 1, 2. And it's going to be slightly slower than performing a bunch of unit tests. Our system test over here, on the other hand, is going to be the slowest because we're checking the overall functionality of our system as well as our acceptance test. Our acceptance test, we are creating scenarios to check the overall use of our system to create an account. So we have a user right here where we're going to create a user account for a new bank account. This will be a very slow process in comparison to our other tests. It's not going to be insanely slow, but it's just going to be slower than the other ones. Also, we're going to have another broad test to check that another user wants to deposit and withdraw money. So I'm going to have a deposit and withdraw. The user is going to deposit an initial amount. It's going to withdraw money. We're going to check the balance, and then we're going to check the transaction history. And in this acceptance test, we're checking the overall functionality of our system to see that everything works properly before we send this out. When we're performing these tests, we can run this in a system such as Maven, so we can check the overall function of our accounts. And these are just some examples of how testing works with JUnit. All right, that's all for my individual assignment and presentation. If there's any more questions, feel free to let me know. And if you feel like I missed anything, please let me know. Thank you.